All right, here we go. What we're going to be talking about today is arc length. All right, we're still in section 4-2 dealing with degrees and radians. Now, everybody here should already know what arc length is. So let's review it, just in case you don't. So right now, we've got a circle. And if I said, what's the distance all the way around a circle, you'd say, well, that would be the circumference, Mr. Dude. And what's the formula for circumference? You'd say, well, that's just 2 times pi times the radius. So I'm going to draw a little circle right here. I'm going to make a radius. Okay. I'm going to call this length from the center of the circle to the outermost point of the circle is the radius. And the distance all the way around the circle, like if I went like that, that would be called the circumference. Okay? But arc length is just a portion of the circle's circumference. So what if you had 30 degrees, like right about there? So I have 30 degrees. That means right now I'm saying theta in degrees is equal to 30. What would the arc length be? It would be this arc length. Why do they call it arc length? Because it's part of the arc and it's dealing with the distance of that arc. So, back in geometry, you may have learned a formula dealing with arc length, so I'm going to write that formula down to start out with the arc length. In words, arc length equals the circumference of the circle multiplied by the degree that you're looking for out of 360 degrees. Now, in the textbook, you will notice that the arc length has a letter called S. So we're going to call arc length is always S. The circumference is 2 times pi times r, and the degree that we have is actually 30 degrees out of 360. Now we also have the radius. What does it say the radius is? 8 yards. We put 8 yards right there. And now I'm going to take the 8 and plug it in. Take 8 yards and plug it right in. So this is what it would look like. 2 times pi times 8. I'm not going to write yards. So that's 8 yards. Multiplied by 30 divided by 360. That's how I'm going to write it in the calculator. I'm going to plug all that in the calculator and press enter. Alright, so here we go. We're continuing right now. Clear that out. 2. Josiah gave you permission. Alright, so 2 pi times 8 times 30 degrees out of a total of 360. And you get an approximate value of 4.18. Rounded to the nearest tenth is 4.2 yards. So your answer for this problem, problem number 11, is 4.2 yards. But what is this title of this chapter in this section called? Degrees and radians. So we're going to show you how to do this in radians, not just degrees. So we're going to do the exact same problem, except we're going to do it in radians. So the first thing I'm going to do is I'm going to take 30 degrees. And you have to know how to take 30 degrees, and you need to know how to convert it into how many radians is 30 degrees. So we're going to take 30 degrees, we're going to multiply by 180. So there, pi divided by 180, when you multiply it, you get 30 pi over 180, and that reduces to pi over 6 radians. So 30 degrees, everybody, is actually equal or equivalent to pi over 6 radians. So these are the same. If I say 30 degrees, you say pi over 6 radians. 30 degrees.
Pi over 6 radians.
There you go. Good job. All right. Pi over 6 radians.
30 degrees.
Good job. All right. Now, here's the formula. In radians, so this is your formula for arc length. When you're not dealing with degrees, you're dealing specifically with radians. Here we go. What letter did I say arc length is equal to? The letter S. We're going to say S is equal to theta times r. I know, it's a really long, ginormous formula. Hard to remember, but that's what it is. Now, theta must be, in order for this to work, theta must be in radians. So what is r theta? R theta was pi over 6. What was r radius? 8. So I can take pi over 6, multiply it by 8, and what should that calculator spit out? 4.2 yards. Well, you know what? I don't want you just to believe me. We're going to go ahead and do it. 5, 6 times the number 8. Cross your fingers and toes. 12. So that means this is your formula you would use if your theta is in radians. You could convert your degrees to radians and use it, or if you wanted to, you could use this formula right here. More specifically, that's kind of an example of how to use it. So this little tiny arc length right here turned out to be about 4.2 yards, and that was our answer. All right, moving on. We're going to go ahead and go down to problem number 13. Please put problem number 13 in your journal. All right, so right now we have this funny looking little W looking thing right here. Okay? And that right here is talking about the angular speed. Okay? The angular speed. Now what the heck is angular speed? So I'm going to try to demonstrate something to you. Right now I'm going to make a circle right here. I'm going to put a radius right there in that circle. And right now I'm going to have a certain speed. Alright, if this was rotated. That has a certain angular speed. There's so many angles. The theta is going at a certain rate. So many radians per second. Okay? Now all the way around this is how many radians? All the way around one time is 2 pi radians. This would be half of a pi radians. This would be a whole pi radians. Right? So all the way around the circle is 360 degrees, but all the way around the circle is also 2 pi radians. So here's what I want you to do. I want you guys to write down this. 1 revolution. 1 revolution is equal to 360 degrees, but that 1 revolution is also equal to 2 pi radians. That's a pretty important concept just to have in your journal. Like, okay, it's 1 revolution, right? 360 degrees, 2 pi radians. That's just a standard you need to know. Okay? Now, W, okay, angular speed, velocity, is equal to theta. Now, theta is going to be in radians, okay, per period of time. So T equals time. So sometimes time can be seconds, sometimes it can be minutes, it could be hours, okay? So right now, it's this theta in radians per unit time. So what I'd like you to do in your journal is make sure you have this with this guy. Okay, so angular speed, W, is equal to what? It's equal to theta over time. Okay? So right now, it's kind of hard for you guys to picture right now 4 fifths pi radians per second. So I want you guys to write that down. 4 fifths times pi radians rad over 1 second. Right? So what would that be? What would 4 fifths pi? What would 4 fifths times pi? If I change that to degrees, what would I have to multiply that by? I'd have to multiply by 180 over pi. So these pi's will cancel out. And in degrees, we would be left with 720 over 5, which I believe is 144 degrees. Now, what does that mean? That means every single second, how far does it go? It goes from here to where? To about there. It's about 145. Maybe not 1. I'm going to say that's about, sorry, not 145, 144. So right now, in degrees, what would theta be in degrees? 144. What is it in radians? 4/5 times. Now, I realize right now, you're probably wondering, well, what are we trying to solve? So this is what we're trying to solve. We're trying to figure out right now, what are my revolutions per minute? That's what we're going to be trying to figure out. How many revolutions per minute are happening if you're traveling 4/5 pi radians per second? So what I'm going to do is I'm going to do a little dimensional analysis right here. Okay, a little dimensional analysis. Now, we're trying to convert from seconds to what? Seconds to minutes. So right up here, I'm going to put, there are 60 seconds in 1 minute. So what's going to happen with this right now? Right now, this second will cancel out this second, and now it won't be out of seconds, it will be out of minutes. Now this right here, 4/5 pi radians, we want to know what? Revolutions, right? So I'm going to put 1 revolution, 1 ReV. What is 1 revolution always equal to in radians? 1 revolution is always equal to 2 pi radians. I'll put 2 pi rad. Okay? So what's going to happen here? This radian, right, is going to cancel out this radian. This pi right here will also cancel out that pi. And what are we left with? What's left standing? We've got a 4/5, right? What is 4/5 can be multiplied by? Times 60. And what's that all going to be divided by? Just the 2. Because 4/5 times 60 times 1 is 4/5 times 60. And 1 times 1 times 2 is 2. Everything else cancels out. Okay? So, by the way, in the calculator you can do this. We're just going to do it in our heads right here. What? Does 5 go into 60? If I had 4/5 like this, 4/5 times 60. 5 goes into 60 12 times. 4 times 12 is 48. 48 divided by 2 is 24. So your answer is 24 revolutions per what? Per 1 minute. What's the only thing you have left? You've got a revolution up here, and what's the only thing you have left down here? A minute. So it's 24 revolutions per minute. What does that mean? That means that the speed at which this is going around, you're going in a minute's time, 24 of those going around. That's what's happening. Alright, what I'm going to do right now is I'm going to zoom out just a little bit so you guys kind of know where we're headed. Here we go. Oh, too far. Too close. Just maybe. There we go. Alright, so here's what we did. It said, find the rotations in what? Revolutions per minute given the angular speed. So what was this? This answer was what? 24 revolutions per minute. So that was the answer to 13. Now number 14, we aren't given the same thing. We're given v. Now understand, v is what's called linear velocity. So I want you guys right now in your journal to write v equals linear velocity. Oh, just spell it correctly. Velocity. There we go. Linear velocity. Okay? So the linear velocity is this. That's the linear. It's going 32 meters per second. Alright? Now this right here is 100 revolutions per minute. This right here, everybody, represents what's called the rate of rotation. Okay? That's the rate of rotation. So this time we're actually not going to be finding the angular speed. We're actually going to be finding the length of the radius given the linear speed and the rate of rotation. So the linear speed, linear velocity, this is also called angular velocity, angular speed. Okay, velocity just has speed with a certain direction. Okay. So right now, what I'd like us to do is I'd like us to build a circle. For number 14, put number 14 in your journal. I want you guys to make a circle. okay? And I want you to make a radius in the circle, right here. I'm going to label that the radius, because that's what we're trying to find. And I want you to understand, think of this as a wheel, okay? Think of it as a wheel. And this wheel is traveling at a speed of 32 meters, okay? Every single second. So every single second, it is traveling 32 meters. So honestly, what we have to figure out is, would you agree that if these wheels right here had the same angular velocity, they're not going to travel at the same linear velocity. So we're going to give you some examples real quick. Let's say I said this was 5 meters, and I said this was 2 meters, okay? What's the circumference of this circle? This circumference would be what? 2, come on, 2 pi times 5. And this would be 2 pi times 2. So this equals 10 pi. This would equal 4 pi. So the circumference of this is quite larger than the circumference of this. So basically it's 2.5 times bigger. So the distance traveled, let's go ahead, if I type that in, that would be what? 31.4 meters, right? And this would be what? Let's see here, let's do 4 times pi. What's 4 pi? Should know this. 12.6. So this is approximately equal to 12.6 meters. So every single time this turns one time, it goes what? 31.4. Every single time this turns one time, it goes 12.6. So if this turns this distance, all right, in 1 second, all right, it would travel what? 31.4 meters per second. If it took 1 second for it to travel. This one would take, if this traveled that in 1 second, that would go 12.6 meters per second. But they already gave us the what? They already gave us the rate of rotation. So we need to kind of use this information. So here we go. Take the rate of rotation, which is what? 100 revolutions in 1 minute. So 100 revolutions in a minute. That matters. We have to convert this. We have to convert this to seconds. We're going to convert this to seconds. Now, what's 1 revolution equal to every single time? 1 revolution is equal to 2 times pi radians. Okay? 2 pi radians, everybody. And right now, I want to convert this from minutes to what? Minutes to seconds. So right now, I'm going to divide this by 60 seconds in 1 minute. So right now, I realize, hold on. Here we go. 1 revolution is 2 pi radians. There are what? There are 60 seconds in 1 minute. So what's going to cancel out? The revolutions are going to cancel out. The minutes are going to cancel out. And what are we going to be left with? Radians per second. So we're going to be left with, up here, 200 pi radians over 60 seconds. Now everybody, this right here is W. This is your angular velocity or angular speed. This is how fast the radius is going around the circle. Now this will reduce to 10 pi over 3 radians per second. So right now, everybody, this right here, I want you to call it this. This is equal to your angular speed. So W equals this. Take that. Now, we're going to take this and help us find our ultimate radius. Now, there is a formula, okay? There's a formula that deals specifically with V, Okay? V is equal. Now what is V equal? Linear velocity or linear speed. So linear speed. Okay? It equals something over something. Right now, the formula for linear speed is S. What does S stand for? S stands for arc length. Over time. Like how much of an arc is traveling over time. What is S equal to? The arc length is equal to theta times the radius. So this is what I want you guys to do. I want you to say V equals theta times the radius per unit of time. Okay? Per unit time. So right now, what is our velocity? What did they tell us our velocity was? They said it was equal to what? 32 meters per second. Did we figure out what theta is traveling per every second? Were we able to figure that out? We were able to figure out that what's happening every single second. We were able to figure out that that's equal to what? 10 pi radians are happening what? Every single second. So right now, I want you guys to understand. This right here is how far it's traveling every single second. So take this information, where are you going to plug it in? You're going to plug it in right here. Now what time? How far? What's the time for our answer? Our time is equal to 1 second. So right now, this is what I want you to do. Plug in 10 pi over 3. This is the radians that's traveling. This is theta. Okay? Over seconds. And all you have to do to solve for r is divide both sides by the radians, or the how far it's traveling in 1 second. And these will cancel out, and what will that give us the length of? That will give us the length of the radius. Okay? So right now in the calculator, I'm going to go alpha y equals enter. I'm going to type in 32 meters per second divided by parentheses 10 divided by 3 pi. Enter. So the length of our radius, everybody, is about 3.06 meters. Okay? That's the length of our radius. So we go back. Right over here. When these cancel out, our radius is approximately equal to 3.06 meters. Which means this. If I have a circle, and I said that circle right there, everybody, had a radius of 3.06 meters. And what was the rate? What was the rate of revolution? It was traveling how fast per minute? What was it? 100. So this was traveling at 100 revolutions per 1 minute. And we converted that. How fast is that going? Okay? That was going what? 4 pi. 4 pi. Sorry. That was going 10 pi over 3 radians per what? Radians per second. Okay? That's how far it was going. Remember, radians is theta. If you multiply everything back together, if you multiply this, radians per second, times this, it gets you back to 32 meters per second. Okay? If you do 3.06 times this, that gets you back to 32 meters per second. Because what's our formula, everybody? Our formula for that, this is arc length divided by time. Very last problem we're going to do is we're going to find what's called the area of the sector. Right now I'm going to draw a circle. This circle has a certain radius. We're going to label the radius as 14 inches. 14 inches. Now, what is theta equal to? Theta is equal to pi over 6. So if we wanted to convert pi over 6 to degrees, what would we multiply that by? We would multiply it by 180 over pi. The pi's cancel out, and that's going to become 30 degrees. So let's make a 30-degree angle, everybody, to the best of our ability. The area of the sector, everybody, is the area of this. Think of it as a slice of pizza. That's the area of a sector. Now, there's two ways to find the area of a sector. Just like there was two ways to find arc length. So I'm going to show you two ways. One of them is if you use degrees. The last one is if you use radians. So here's the degrees formula. Here's the radians formula. Now, what's the area of a whole circle? The area of a whole circle is pi r squared. That's how many degrees are in a circle. The area of a circle is pi r squared. If you wanted to find the area of a sector, put A, that's going to equal pi r squared times the degree that you have out of 360. The formula for radians, if you want to find the area of the circle, not area of the sector, it's going to be 1/2 r squared times theta. But theta has to be in radians. So we're going to plug this in. We're going to plug it into the calculator so you see it works both ways. So here we go. Pi. What's our radius? 14. What's our degree? 30. That's how I would plug it into the calculator to get my approximate value. Over here, I have 1/2. My radius is still what? 14. But this time, in radians, what do they tell us our theta was equal to? It says theta is equal to pi over 6. So I'm simply going to write pi over 6. I'm going to get an approximate answer. So I'll have an approximate answer. If I use degrees, I'll have an approximate answer for radians. And if we did everything right, they should be the same answer. So now we're going to check using the calculator. Here we go. In degrees, I'm going to clear this up. I'm going to type in pi times 14 squared, and we had 30 degrees, right, out of 360. So this would be the area of the sector if we were to use the degree formula. Now I'm going to use the other formula, on the radius. 1/2. What did I say? 14, the radius squared. And then I multiply it by pi over 6. Just remove. Why does this have pi r squared and that doesn't have another pi? Because you know what? In radians, it's already in terms of what? It's already in terms of pi. And you get the exact same area. No matter which formula you use, you get the exact same area. So our answer was what? 51.3. Now make sure you give it a name. Call it inches squared. Inches squared. You have the rest of these to do on your own. Alright? You're either finding arc length, you're either finding angular speed, linear speed, or you're finding the area of a sector. Those are all the formulas you should have. So solve the rest of it on your own.